for our last pilot, we still have to talk about the pilot, which is a demonstration in Barcelona. And for that, we have our associate partner, District Lima.
Okay. Hello, everybody. You hear me well?
Yes, perfectly. Thank you.
Okay. I will just prepare the presentation to share. A second. So again, thank you very much for letting me participating in the District Lima in this summit. And well, I will present what is the district heating and cooling network that we have in Barcelona, which we will see now that it's a successful story of heat recovery. Okay, so first we will talk about the context. Okay, the context is that there are two figures here in this slide that are very important. For the first, it's known that more than 50% of the energy consumed in Europe is used for climatization purposes. Okay, both heating and cooling, and we have seen that there is a big increased demand on refrigeration. So there is an estimation of a 200% increase of cooling demand from 2016 until 2050. So with those figures, we have to understand that district heating and cooling systems have to be considered as a tool that can help not only the decarbonize cities, but becoming more efficient, more independent on energy uses. So, you are aware that district heating networks has existed for many years, but what we need to understand is how we can turn them into smart infrastructures. So conceiving a smart district heating and cooling, it requires, of course, to be a sustainable and renewable energy source, but that's not enough to be sustainable. You need to be efficient in order to consume less primary resources. This needs to be followed and helped by a digital platform. What I'm displaying now is the digital twin of the network that we have. That allows us to simulate different conditions, and using less resources in order to produce more energy. So in this case, we can see the delta P, the difference of pressures from the supply and return of the district cooling network. And at the end, there is a maybe strange concept, which is the flexible design. When we talk about flexible design, is that when you design a district heating and cooling network, you need to have this picture of the evolution of the uses in the city. So there may be some areas that may turn offices into residential uses or other. So it is important to have a good cooperation with the authorities of the municipality in order to have this long-term view of how it will change, the city. And all that, it's because, this type of networks not only helps to improve the air quality, but they are a good system together with, in order to decrease the electricity consumption. We are now using electricity for other uses. Electrification has come to mobility. Electric mobility is taking a part of this. Now the disruption of AI and data centers is also taking a big part of this electricity. So the networks are saturated. So a district heating and cooling system helps to use electricity for other uses, as well as they allow to integrate local energy sources, as we will see in the case of District Lima. There is also an important point to have into account that when coming to district cooling systems, they allow to reduce and mitigate the heat island effect. The heat island effect is the difference between what the temperature that you have in the center of the cities and the temperature in the surroundings. So having individual air-conditioned systems, they are just pumping the heat from inside the houses outside, and this makes increase the temperature by there are studies that are pointing that that just because of this effect, it's about a temperature increase of 1.5 to 2.5 degrees. For real estate developers, it has many benefits, but of course, when you have this type of systems, then you can obtain a more free area or rooftops to do other activities or to use it for other renewable production installations. So District Lima. Well, District Lima, it is a private-public partnership between ENGIE and two public companies, one Tersa, which is represented from Barcelona municipality, and IDAE, which is the energy agency of Spain. ENGIE has the know-how and currently owns and operates around 400 district heating networks around the world. So coming to the key figures of the District Lima network, well, you have to understand that it's a dual network, both for heating and cooling, and we have now around 200 buildings, big buildings connected, with a length of 26 kilometers and a total installed capacity of around 50 megawatt in heating and 50 in cooling. In cooling, in addition, and that's the focus of this collaboration with Storm Project, we have accumulation both in cold water and an ice storage tank. So the layout of the district heating network is the one that I'm displaying. You will see that we have a big variety of type of customers, such hotels, hospitals, and also even critical customers such hospitals or data centers. This mix of users allows us to have a quite base demand, and that allows us also to anticipate what will be the demand depending on the day. If it's a Monday or if it's a Sunday, if there's an special event in Barcelona and we expect more occupancy in the hotels. So by anticipating the demand, we can choose the most effective resources to produce and to satisfy the demand. So the first plant, it was the Forum plant, which is the one that I'm showing just here. And it's in a strategic location because it's very close to the harbor, where we have a seawater captation that allows us to increase the performance of the chillers. And as well, it's placed just nearby the waste incineration plant of Barcelona. When District Lima was conceived, the idea was to recover the heat, the excess of heat that previously was being thrown to the Besòs River. So that was the idea, to collect this heat, not only to produce or to satisfy the heating demand, but also using it to produce cooling capacity thanks to absorption chillers. Then afterwards, with the increasing demand, we deployed the second facility, which is Tànger plant. And now, finally, in April, we started the operation of the third plant, which is Bogatell. So now I will go in details in those plants. Here you have some details of how it looks like. It can. The network is deployed both aerial via through the buildings or underground. So we have both It's a 4-pipe system, pre-insulated, with heating and cooling, supply and return. Now, the first plant that was built on 2004 is a forum plant, which is built below this artificial hill, as you see. And but then we have an important storage, hot water storage tank. Is this black box that you can see that pops out. It's a 12-meter high tank with 5,000 cubic meters. This allows us to accumulate around roughly 40 megawatt hours. So the equipment that we have are 2 absorption chillers that can use the excess heat that is not used during summer, coming from the waste facility, waste treatment facility. And then we have the chillers that are condensed with seawater. Finally, heating is produced with 4 heat exchangers, steam, hot water. Now, the second plant that was built around 2010 it was planned to be a backup system that helped us in order to give always continuous service 24/7. And it is interesting because this plant includes an ice storage tank, which has a capacity of 2,500 cubic meters, and that allows us to store around 120 megawatt hours. This storage tank is placed underground, okay, and we can store ice thanks that we have 3 chillers. 2 of them can either provide negative temperatures at -7 degrees, or just produce towards the network, producing positive temperatures at 4 degrees. Apart of this, we have a multi-compressor chiller that has 10 magnetic levitation compressors that helps us to increase efficiency, because this is the chiller that attends the variable demand. So how it works? Well, now we can see here a picture, of how are these storage ice storage tanks. In them, we have coils where we run water at 7 -0 degrees, water with glycol, and all this is filled up with water without glycol. So around the coils, we start building ice. We also use a system with we inject air, and the bubbles that comes from below helps to mechanically detach this ice and increase the total accumulation. It's important to understand that when storing cooling, you need more space than with heating, just because of the delta T, the delta temperature that you have in climatization for refrigeration in comparison with heating. And the case is that before we saw that the storage accumulation that we have in Forum is 5,000 cubic meters, and that gives us up to 40 megawatt hour. But when coming here, since we are taking the benefit of change of phase into ice with half of the volume, so we said that in the ice storage tank is 2,500 cubic meters, we can store 120 megawatt hours. So there is a ratio of 6 times less space when using change of phase with ice. Now, the new brand new plant that we have started operations now in April and we are already producing a big part of the demand from this plant. This is the most advanced plant right now in the Southern Europe, with a capacity that will, in the third phase, will achieve 56 megawatt of capacity of production of cooling. And in the third phase of construction, it will integrate a cold water storage tank with a capacity that will double the one that we have now, so around 120 megawatt hours. Now, this plant is constructed underground, so it's invisible. Now we can see the layout. It has a seawater captation with a length of around 800 meters out from the sea. So this helps us to achieve colder temperatures that in comparison with the Forum plant, where the captation is done inside the harbor. So here the water is collected at a depth of around 14 meters. So this was a very complex project, since the whole facility is built below the sea level, and so it needed of all this piloting system when constructing it. Here we can see the size, and to have an idea of the construction works that were done last year. And the concept, the complexity is that we had to use a boring machine in order to be able to cross below Las Rondas, which is the circulation ring of the city, and finally arriving to the collection towers. Some details of the boring machine. This is a 2 meters tunnel, and finally the operation, how we rescued the front part of the machine. Then at the end of this water intake, we have these collecting towers that we try to increase as much possible the surface, so the speed of the intake was the lowest possible. So yeah, as we said, we are working with different type of buildings, mainly our offices, but then we have hotels, big hospitals, okay, that they are critic. Then we have also some universities and educational centers. Also housing. In housing, since we have a dual network, some houses may only connect to the district heating system. And finally, of course, different type of public facilities, such as museums or public offices, etc. When building a district heating and cooling network, you have to have this long view investments, let's say, because at the beginning you have to invest a lot on the production plants, and you may have a few customers, so it's important to have this focus. So I would say that part of the success of District Lima has been this model, that is this private-public partnership that allows us to have this agreement now for a long-term period, let's say 30 to 40 years, in order to be able to have a return on the investment. Now, well, of course, this helps the city in order to reduce the CO2 emissions and to achieve the goals of the 2030 agenda. One key point is also the reduction of water consumption in places where you are using condensation towers to produce cooling. They use a lot of water. In our case, instead, we are using seawater. Okay, and all that helps the buildings to obtain a higher energy certification. Certificates such LEED or BREEAM with District Lima, and the buildings can increase the number of the points that they obtain. So at the end, this reverts on a higher value of the building itself. So here we have some other example of buildings that has obtained LEED Gold certificates, and even platinum, as we can see here. So yeah, that was to have an idea of the network. Please, you can visit districtlima.com in order to understand what we are doing, and there you will find more detailed information. And of course, my email is available. You can contact me for any questions you may have.
Thank you, Joan, for this presentation. Very interesting to see the scale that these applications can go up to. And I would like to thank District Lima for supporting STORM and being an associate partner. And we are looking forward to the steering committee meeting that will happen in Barcelona maybe a year from now. And it will be an opportunity maybe to visit one of these sites in person. Thank you very much, Joan. Thank you.
Thank you.